Hey team, so 10.3 is once again about angles and arcs, but it's not about central angles anymore. It's about another type of angle called inscribed angles. Okay, so inscribed angles are different from central angles. Remember, central angles are the ones that the vertex is on the center of the circle. All right, inscribed angles, once again, on a circle. Okay, inscribed angles are going to have the vertex on the circle, actually. Okay, so an inscribed angle is going to have a vertex here, and it's going to be like, going all the way across the triangle like that. Okay, so if you notice, both sides of the angle are chords, right? And all the ends are on the circle. Okay, that's an inscribed angle. Now, what's the arcs here, rather than called major minor arcs, they're called intercepted arcs. Okay, so right here in blue, this right here is called an intercepted arc. Right, and we're going to learn about there's a relationship between this angle right here and this arc right here, just like central angles. Remember, the central angle was the same as the arc that it created. It's not going to be the same, it's going to be a little bit different, but I'll teach you in just a little bit what that relationship is. So the other definition here is an inscribed polygon. So I think we talked about this a while ago back in chapter 6, but just to go over it again, okay? An inscribed polygon is any polygon that has all the vertices on the circle. Okay, so here in green, I'm going to show you. This is an inscribed quadrilateral. Okay? Alright, so that's an inscribed quadrilateral. Right, all the vertices, as you notice, are on the circle, all four of them. Right, and they don't go outside of it ever. Okay, so it's basically a whole bunch of, hopefully you see this, a whole bunch of intercepted arcs and those angles. Okay, so you see all these angles with the intercepted arcs. Okay, you see all those. Now, how we're going to put this all together. Okay, so the inscribed angle theorem, it tells us that relationship between the inscribed angles and the intercepted arcs. All right, so if I draw okay, so there's an inscribed angle, right? And that angle is, let's call it x. Okay, so if I draw the inscribed angle and it's x degrees, then the intercepted arc for that is going to be 2 times that angle. So the intercepted arc here is going to be 2x degrees, right? So very, very quick example. If the blue one, the angle here, was 70 degrees, then the intercepted arc here is 140 degrees. Okay? Very simple. Let's go to the examples. Oh no, a couple more theorems here. So the congruent inscribed angles theorem is pretty simple for us. All right? If you have two angles that create the same intercepted arc, then those angles have to be congruent. Okay, so if I draw this angle, right? But I also draw this angle. Okay, and let's say I also draw this angle. Oop, I'm on the wrong side there. This angle. Okay, now you notice that all of those three angles create the same exact intercepted arc. So if you see here in purple, they all create that intercepted arc. Okay, so if I tell you that intercepted arc is 200 degrees, then you would know that all of these angles would equal 100 degrees. Okay, so this one, and this one all would have to be 100 degrees. All right, that's what this means. Now, inscribed right triangle theorem is a special case of this. Okay, now if you inscribe a right triangle, there's no way to inscribe a right triangle in a circle without the hypotenuse being the diameter. Okay, and let me tell you the reason for that. Because if I just want to create, right, an inscribed angle that has a 90-degree angle, okay, no matter what, this last side here, right, this intercepted arc is always going to be 180 degrees. right? And a 180-degree arc is going to create, it's going to be at the diameter, right? So this right here has to be 90 degrees, right? And it works no matter what. There's no way to draw any right triangle in this circle or in any circle that does not have the hypotenuse as the diameter. And lastly, the inscribed quadrilateral theorem tells us that if you draw a quadrilateral inscribed in a circle, right, so it could be any looking quadrilateral, it doesn't have to be a square or a rectangle or a trapezoid or anything like that. All right, so let's just say that weird quadrilateral right there. All right, so if I draw that and it's inscribed, then the opposite angles are going to be supplementary. Okay, so let me give these A, B, C, D. Okay, so the opposite angles are supplementary. That tells us that this one and this one are supplementary, this one and this one are supplementary. So from this, I'd be able to say angle B plus angle D equals 180 degrees, and angle A plus angle C also equals 180 degrees. And we can see how that could apply to a problem, right? If I give these all numbers or expressions, you could set these equations up and then solve for whatever we need to solve. Now on to the examples. So this first one, I need to make it a little bigger. Okay. This first one here is a nice multiple choice question. Now, what I do is I give you this arc right here and this arc right here, and I want you to find this inscribed angle. So in order to find this inscribed angle, I probably need to find the intercepted arc, because I know I could divide that by 2 to get the angle. All right, so what do I know about this arc and this arc and this arc? Hopefully you figure out that all the way around the circle, all these arcs add up to 360 degrees. So this one plus this one plus this one has to equal 360. So I could set that up. 110 plus 146 plus the measure of arc yx or xy equals 360 degrees. Okay, so I could do that subtraction, and I'm going to do 360 minus 256 degrees, and I'm going to get measure of arc yx equals 104 degrees. We got 104 right there. All right, so if that is 104 degrees, right, our intercepted or inscribed angle theorem tells us that the inscribed angle is half the intercepted arc that it creates. So that means that this angle here has to be 104 divided by 2, which equals 52 degrees, which we see here is A. Second problem, number 2. Okay, so what we're going to do here is we're just going to find the measures of the angle and the arc. We're going to find this angle right here, and we'll find this arc. We could just find all the arcs. I'll go ahead and find all of them. So, starting with this angle, okay? If we need to find that angle, what you guys need to be able to see here is that this angle and this angle have the same exact intercepted arc. All right, so since they have the same intercepted arcs, that means that those angles have to be congruent. So, angle M has to be the same as angle L, which makes it 68 degrees. All right? Over here, arc and P, okay, then has to be double its angles. So 68 times 2, which gives us 136 degrees. All right. Now, another thing you can notice here is we have a diameter. Okay, since we have a diameter, it means it cuts this into a semicircle, 2 semicircles. Okay, so you can get these 2 arcs by subtracting from 180 degrees. Right, we see this has to be 180, and since that one's 92, this one's got to be 88. And over here, this whole thing's 180, this one's 136, so subtract it, and you get 44 degrees. Now that we have all the arcs, we can get all the inscribed angles. Okay, so if we're going to look for an inscribed angle, let's look at this angle right here. Remember, you've got to trace the angle and figure out what's the arc that it creates. Well, it creates this arc right here, which is 88 degrees. If you divide that by 2, you can get the angle. Remember that the angle is half the arc that it creates. Okay, so 88 divided by 2 tells us this one is 44 degrees. And this arc right here is 44. So that means that this angle that it creates is 44 divided by 2, which is 22 degrees. All right, and lastly, this one, right, is 92 degrees. So 92 divided by 2 is going to get us this angle. Do that division, you're going to get 46 degrees. And you should see that this angle creates the same exact arc as this angle, so it's also got to be 44 degrees right there. All right, that's all the angles, all the arcs that we can find from that problem. Number 3 here, all right, you see that we've got an inscribed quadrilateral. It's a quadrilateral because it's got 4 sides, and all the vertices are on the circle. So remember that for an inscribed quadrilateral, the opposite angles, ones not next to each other, not adjacent to each other, are supplementary. So that means these two are supplementary, those two are supplementary. That gives us 2 possible equations we can create. 12y minus 2 plus x plus 98 equals 180, and negative 1 plus 17y plus 2x plus 62 also equals 180. So that sets up our equation. Now we have a system of equations, right? You got to be able to put those together, right, through substitution or elimination, and solve this multiple choice problem. You guys can finish that at home. Now number 4 here. Okay, we have to solve this problem. We want to solve for x is what we're looking for. All right, we see this relationship between the inscribed angle and the intercepted arc. Okay, we have this angle, and you see that it creates this arc right here. So we need to come up with a way to combine those into an equation so we could solve for x. Well, remember, we know that the angle is half the arc, or the arc is 2 times the angle. I'd prefer to use the 2 rather than the 1/2. So I'm going to write this equation. The angle, right, the arc is 2 times the angle. Okay? So we can distribute this. I get 5x plus 60 equals 6x plus 50. Solve for x. Get all the x's to the right, get all the numbers to the left, and you're going to get x equals 10. Just like that. And the last problem here, number 5, we see we have an inscribed angle, and we have an intercepted arc, but we don't know what the intercepted arc is. Well, hopefully you see here that the angle creates a diameter, okay? Creates a semicircle. This is a diameter. So that tells us this has to be a right angle. So if this is a right angle, we know that right here this has to equal 90 degrees. So 2x plus 6 equals 90. And you could solve for x now. 2x equals 84. And x equals 42. Okay guys, finish up number 3. We'll have a homework quiz at the beginning of class.